All right, let's take a look at our practice test. We're told to simplify each. And for our problems today, we're going to assume that all variables are positive real numbers. So this is going to stop us from needing to use absolute value bars. Okay, let's look at the first problem. So we have the square root of 96x. So the idea here is that if you have a square root, you're going to factor this number and you're going to look for any perfect squares. Okay, that's going to allow you to further break this down and simplify. So I'm just going to start by making a little factor tree for 96. And I'm going to think about dividing it by 2. So it would be 2 times 48 just to get things started. We know 2 is prime. And then 48, I can do 4 times 12. 4 is 2 times 2. Let's circle those. And 12 is 4 times 3. Let's circle that. And then 4 is 2 times 2. Okay. So if I'm looking for perfect squares, let's see. We have 1, 2, 3, 4, 5 factors of 2, which is 32. And then 1 factor of 3. So this, I'm going to say, is 2 to the 5th power, and then times 3 like this. So what I would do here is say that if I wanted this in terms of perfect squares, I would look for an even number here. So let me rewrite this and say that 96 is 2 to the 4th power times 2 times 3. 2 to the 4th power could be written as 2 squared being squared. So in other words, this could be 4 squared like this, and this would be a perfect square, 16. So I'm going to break this down into the square root of this 16 times the square root of what's left, which is going to be 6. And then don't forget about this variable here. You have this x, so you want to make sure that's in there. So by breaking up the square root into these two guys, let me put equals here, and let me drag this up here. I can legally simplify this part, right? Because the square root of 16 is just 4. So the idea here is I'm just going to replace this with a 4. So I'll have 4 times the square root of 6x. So that's all I can do. That's going to be my simplified answer. Okay, let's look at problem number 2. So now we have the square root of 180x cubed. Okay, so the same idea. You want to factor 180 and you want to look for perfect squares. So 180, this ends in a 0, so I'm going to do 18 times 10. And then 18, I'm going to do 9 times 2. 10, I'm going to do 5 times 2. 9, I'm going to do 3 times 3. So what am I looking for here? Let me go ahead and write this as what? 3 times 3, so 3 squared. And then times, you have 2 times 2, or 2 squared, and then times 5. And you could circle these if you want to make this complete like this. But essentially, I have 3 squared times 2 squared times 5 squared. So I could really rewrite this. I could say 180 is equal to 3 times 2 like this, being squared, and then times 5. What is 3 times 2? That's 6. So this is 6 squared, or 36 times 5. So 36 is the perfect square that I'm looking for there. So let me rewrite this. I think we can remember this. I'll just go ahead and erase this. I'll say this is the square root of 36. I'll deal with the variable in a second. And then times the square root of 5 like this. Okay, now variable-wise, I have x cubed. I don't need to go through and factor that. I know that if I want to take the perfect square part out, I'm just going to write this as x squared. So I'm going to match this number here, this exponent, with this index here, which is an invisible 2, so we don't have to write that. And then what would be left over? Well, I would need an x here, right? Because x squared times x would give me x cubed. Okay, so this guy right here is what I can simplify. This would basically just be 6x. So I'm just going to replace that and say this is 6x and then times the square root of 5x like that. All right, let's take a look at problem number 3. So we have the 7th root of 512x squared. So the idea here is I would think about 512. You could make a factor tree, but this one's pretty simple. 512 is really 2 to the 9th power. Okay, so when we think about this index of a 7 here, I want to match that up with this guy here. So I could say 512 is 2 to the 7th power times 2 squared. Or in other words, this right here is 128, okay, times this right here is 4. So this is how I would break 512 up in order to simplify. So let's put equals. I'm going to put the 7th root. I'm going to take that 128. Now, some people would prefer to write 2 to the 7th power here so they can cancel this index with this exponent and just be left with the 2. It's really up to you how you're going to write it. I'm just going to put 128 there. So then we're going to multiply this by what's not going to simplify? Well, it's going to be the 4 part. So let's put the 7th root. We'll put the 4 part. And then don't forget about this x squared that you have here. So we'll put x squared like this. Okay, so now what I'm going to do, let me actually erase this and make this a little bit cleaner. I'm going to drag this up here like this. And let me put this equal sign down here. This part right here, we know is going to simplify to 2. So let me put a 2 there. And then this part right here, I can't do anything with that, so it just comes along for the ride. So 2 times the 7th root of 4x squared. Okay, let's look at problem number 4. So we have the 4th root of 80x to the 7th power. So again, let me start out with 80 and think about what this would be. So I know off the top of my head, this is 5 times 16, and 16 is 2 to the 4th power. So I can say that I have the 4th root of 16, and then times the 4th root of what would be left over would be that 5. Now, variable-wise, if you have x to the 7th power, so in other words, if this is greater than or equal to this index here, you're going to be able to simplify. I can just go ahead and say this is x to the 4th power, and I can say this is x cubed, because x to the 4th power times x cubed would give me that x to the 7th power. So what I would do here is basically replace this with 2x. So that will be 2x, and then times your 4th root of 5x cubed. All right, let's take a look at problem number 5. So we have 4 times this cube root of 320x to the 8th power y cubed. All right, so let's think about 320 real quick. And I know this is divisible by 10 because it ends in a 0. So this is 32 times 10. And let's think about 10. It's 5 times 2. And 32, we know, we could go through the process, but it's 2 to the 5th power, right? So I'll go ahead and say that this is 2 to the 6th power times 5. So 2 to the 6th power times 5. So you're not going to be able to do anything with the 5, but think about this. I'm trying to get something that's basically a perfect cube, right? So I want an exponent of 3 there. How could I rewrite that using the rules of exponents? I could say 2 to the blank power raised to the 3rd power. Well, essentially all I would do is divide 6 by 3 to get to 2, right? So basically 2 squared being cubed is the same thing as having 2 to the 6th power. This is 4 being cubed, which is 64, and 2 to the 6th power is also 64. So let's go ahead and put that this is 4, like this, being cubed, and you can replace this with 64 if you want. So we'll say this is 64 times 5. So let's go ahead and say we have 4 times, I'll say the cube root of 64, and I'll deal with the variables in a second. Then times we'll have the cube root of 5, so what's left over. And then for the variables, again, if your exponent is greater than or equal to your index, you're going to be able to simplify. So for this one, I'm going to go ahead and say that I want x to the 6th power, and I'll explain why in a second. Let me slide this down. And then for y, I just want to put the y cubed, right? Because this exponent exactly equals this index right here. So what do I need over there? If I have x to the 6th power, and here it was x to the 8th power, I'm going to need x squared, right? Because x to the 6th power times x squared will get me back to that x to the 8th power. Now, why did I choose x to the 6th power there? Well, again, if you're thinking about this, if you have something like an 8 or a 9 or a 10 or something like that, as you look at it, you would say, is this divisible by this, right? So is 8 divisible by 3? No. So then I would just go down to the next nearest whole number that is. 7 isn't, but 6 is, right? 6 divided by 3 would give me 2. So really, I could write x to the 6th power as what? I could say this is x squared being cubed. And again, all I'm doing is some basic division. If I know power to power rule, I multiply. 2 times 3 gives me 6. Well, then I could divide. 6 divided by 3 would get me back to 2. Okay? And for clarity, if you want, you can write that way. So we can say this is 4 times, we'll go ahead and say the cube root of 64. Let's just go ahead and say that's 4. That's going to be cubed. I'm going to wrap this in a second. So then we're going to have x that's going to be squared, and then y. So all of this I'm going to wrap and cube it. Okay, so we can cancel it, make it more clear. And then we'll put times, we'll have the cube root of 5x squared. So at the end of the day, this index here, this guy is going to cancel with this guy right here, and I'm just going to have this inside left. So I'm going to have 4 multiplied by 4x squared y, and then times the cube root of this 5x squared inside. So let me slide down here a little bit and see what we have left. So 4 times 4 is going to give me 16, and then I have x squared y, and then times this cube root of 5x squared. All right, let's look at problem number 6. So we have negative 6 times the cube root of 64xy to the 5th power. So again, if I think about 64, some of you know it's 4 cubed already, but again, if you had to factor it, you would come to the point where it's 2 to the 6th power. And again, you could always wrap this and say, okay, well, 2 to what power being cubed will get me back to that 2 to the 6th power. 6 divided by 3 would be 2. So you could write it like this and say, okay, well, 2 squared is 4, right? So that's how you can figure that out, again, if you don't know that off the top of your head. So I know, let me rewrite this here. I'll put negative 6 times the cube root of, again, you could put 64 again, or you could put 4 being cubed like this. It's up to you in terms of clarity what you want to do. So you could write it like this, or you can just go back to putting 64. X is not going to be in the part that I'm going to simplify because the exponent here is not large enough. This is a 1 and this is a 3. So I'm not going to put that in there. So let me put, actually I probably need to put this on a new line. Let me put times here. I'll put my cube root of x. And then for y to the 5th power, again, because this exponent here is larger than this index here, I know I can simplify. But I can't put the whole thing in there. 5 is not divisible by 3, right? So I go down to 4 and then to 3. So I want to put a y cubed in here, okay, like this, because the cube root of y cubed is just y. Now what's left over would be 2, right? 5 minus 3 would give me 2, so I want y squared here. Again, if you go back through and do the multiplication, y cubed times y squared gets you right back to that y to the 5th power that you have there, okay? And for clarity, if you want, you can write this as 4y being cubed like this. Again, it's your personal preference. When you first start out, you might have a lot of trouble with this, remembering things. So if you write it like this, you can see that index of 3 is going to cancel with that exponent of 3, and you'll be left with that 4y there. So let's come down here and say this is equal to negative 6 times. Again, the result of this is going to be 4y. And then times, you have your cube root of xy squared. Okay. Now all we really have to do is simplify here. Negative 6 times 4 is negative 24. And then y, and then times the cube root of xy squared like this. All right, let's look at problem number 7. So we have negative 2 times the cube root of 375x squared y to the 4th power z to the 8th power. Let me start by factoring 375. I know it ends with a 5. You divide that on your calculator, you get 75 times 5. And of course, 75 is 25 times 3, and 25 is 5 times 5. So you're going to have 5 times 5 times 5, which is 5 cubed, and then times 3. So basically, I would want to write this as, let's put negative 2 here, then times, I'll go ahead and say the cube root of 125, or again, you could write 5 cubed if you want, and then times over here, let me put the cube root of, I'll go ahead and say this is 3, okay? Now, variable-wise, again, if the exponent here is not as large as the index, you can't simplify. So I'm just going to put x squared in there. Can't do anything because 2 is less than 3. For this guy, I have a 4 and I have a 3, so I can simplify, right? So I can go ahead and say that this would be y cubed, and then this would be y to the 1st power, just y. Again, y cubed times y gets me back to y to the 4th power. Then for z to the 8th power, again, going down, what's the next largest whole number that's going to be divisible by 3? It's not 7, but it is 6, right? So I want z to the 6th power, and then here I want z squared. Z to the 6th power times z squared gets me back to z to the 8th power. Now again, if it's a little bit confusing for you how you would simplify that, again, you can always use your rules of exponents. If you want to write this like this, so you'll say z to some power, raised to the 3rd power like this, well, what goes here, again, divide this by this, 6 divided by 3 is 2, so z squared being cubed. Okay, so you can rewrite this for clarity as negative 2 times the cube root of, instead of 125, I'm going to put 5. Instead of y cubed, I'm going to put y. And instead of z to the 6th power, I'm going to put z squared, okay? And then I'm going to cube this whole thing like this so that it's crystal clear what you're going to have when you simplify. So then times the cube root of 3x squared yz squared. So this extra step is something you can do if you're struggling with this topic. If you have no problems, then I wouldn't take the extra step to do this. I would say, okay, hey, when I simplify, this is going to be 5yz squared, okay? So let's come down here and put equals. So I have negative 2 times, again, the result of this is going to cancel with this, and you'll have what's inside of here. So this guy right here, what's being cubed. So you'll have 5yz squared. Then times, again, this isn't going to simplify at all. So the cube root of 3x squared yz squared. And just to finish things off, I'm just going to multiply. Negative 2 times 5 will give me negative 10. So I'm going to have negative 10, and then yz squared, and then times this cube root of 3x squared yz squared. All right, for problem number 8, we have negative 5 times the square root of 72 x to the 4th power yz squared. So let me put negative 5 out in front. And then for 72, it's 8 times 9. So it's 8 times 9. And 8 is what? It's 2 cubed. So let me write 2 squared times 2. And then times, you would have 3 squared there. So basically, I'm going to rewrite this and put times this 2 times 3 squared like this. 2 times 3 is 6. So you would want to write this as the square root of 36. And basically, let me put times the square root of 2 over here. So let's get rid of that. And then variable-wise, again, this index here is 2, right? It's not shown with a square root, but it's a 2. So is 4 greater than 2? Yes. Is it divisible by 2? Yes. So you can just put x to the 4th power in there. Or again, you can divide it by 2. And you could say this is x squared like that for clarity. So again, it's up to you. And then y, the exponent here is 1. It's not big enough, so it's going to go in here. Then z squared. Again, this is perfectly going to match up, so you can put z squared in there. Okay. So pretty simple from this point right here. So let me write -5 times. This is going to simplify to 6x squared z. Okay. Then times the square root of 2y. So as a final step, let's go ahead and say -5 times 6 is -30. And then x squared z. And then times the square root of 2y. Okay. For the last two problems, there's really a shortcut way to do this. The longer way to do it is with exponents. But I think I'm going to do it both ways here just to show you what's going on. So we have the 5th root of the 9th root of 2x. So at the end of the day, all you really have to do is set up your radical symbol. And you can multiply these two indexes. So 5 times 9 is going to be 45. And then this guy is just going to go underneath. You can't simplify this at all, really. But if you look at this guy, again, in exponential form, I think that's where it makes more sense. So let's say I started out with the 9th root of 2x. How would we do that? You put 2x inside some parentheses. Let's raise it to the 1/9 power. So 1 over whatever the index is. The index is a 9. And then let me go ahead and raise this to the power of 1 over 5. Again, 1 over whatever the index is. The index here is 5. Okay, so using the power to power rule, what do I have? 2x stays the same. Multiply exponents. 1/9 times 1/5 is going to be 1 over 45. And again, you can write this as a radical by saying this is the 45 here for the index, and the radicand is this 2x. So if you want to do this immediately, or if you want to go through all these steps to make this make sense for you, either way, this would be your answer. Okay, so similar concept here. For problem number 10, we have the 5th root of, you have the square root of x plus 1. So again, using the rules of exponents, if you want to do this, you could do x plus 1 like this. Again, this is an implied index of 2, so this is raised to the 1/2 power. And then this guy right here would be raised to the power of 1/5. Again, you could just start out by multiplying those. 5 times 2 is 10. So you know this would be to the power of 1 over 10. So it would be the 10th root of this x plus 1 guy. But again, to do this the long way, multiply the exponents, you get the quantity x plus 1 raised to the power of 1 over 10, which equals, in radical form, again, this index is a 10, and this radicand would just be x plus 1. But if you get something like this on a test, you don't need to go through all these steps. Again, I'm just doing this for clarity. You can just multiply those guys together and basically look at it after the fact and say, hey, can I simplify anything along the way? Can I factor and pull anything out if that's available to me? In this case, you can't, so this is our answer.